Alright, 62701-400 landfill construction requirements. Minimum design standards. The requirements of the rules, minimum standard for the construction of landfill, nothing of the rules constructed to prevent the department from imposing the more stringent standards necessary to protect the environmental, public health, and safety due to the specific conditions, the type of the waste to be disposed in the landfill, and the solid waste disposal unit application with the landfill design. Meet the design standard with the rule with the presumed to provide with the presumed reasonable assurance with the performance standard of the subsection 62701-341 and for the full administration goals will be made. The planned construction closure to landfill should be designed to the solid waste disposal unit with the construction of the subsequent closure for the plan intervals throughout the design period of the landfill. The design prevent the failure of the side slope of the design, prevent the deep sea failure through the waste of along with the liner in the system through the foundation soil shall achieve a minimum factor of safety of 1.5 using the peak strength. The landfill liner the requirements of class 1 of the landfill should be constructed in a composite the double liner of the latch collection with the removal system liner and latch system collection system for the class 3 landfills are addressed in paragraph 62701-403G full administration code. Liners shall be constructed of materials that have the appropriate physical, chemical, mechanical property to prevent the failure due to the physical contact with the waste, the latch to which they are exposed to climatic conditions, and the stress insulation other than applied with the stress and the hydraulic pressure which are anticipated during the operational closed period of the solid waste disposal unit. The supplier of materials of the liner components shall be provided with the test information accepted with the engineering of the record to support the capability of the materials to meet the standards and to install with the base in the geological setting the capability of providing the structural support and preventing overstressing of the liner due to the settlements applied with the stress constructed so that the bottom of the liner and system is not subject to fluctuation with the groundwater so that it adversely impacts the integrity of the liner system. Through forward the design hydrostatic uplift within the liner located below the sea is an high groundwater table installed with the cover all the surrounding area earth which could come in contact with the waste of the latch as the liner the upper component with the composite liner shall be 60 minimum average thickness of HDPE geomembrane. The primary latch collection removal system drainage layer shall be installed with above the geomembrane liner except for the sumps and latch collection trenches. The system shall be designed to limit the latch head above the liner during the routine landfill operations of the placement with the initial cover that's specified in table A below. Depending upon the thickest hydraulic conductivity of the lower component of the composite liner, the latch head of the calculation should consider latch recirculation with the fully sheet. Latch is recirculated with the lower component with the composite liner shall be constructed with a 6-inch lift. The thickness of the lower component may be varied in relation to the hydroconductivity of the lower component with the design latch head above the liner in accordance with the table A. Table A, minimum thickness of the lower of the component with the composite liner and feet of the maximum designs of hydraulic head of inches and maximum hydraulic conductivity in symmetric versus seconds. The double liner system shall consist of upper loaner with 60 minimum average thickness for the HDPG membranes with a primary latch collection removal line system above the upper geomembrane designed to limit the latch head of one of the foot above the liner during the routine landfill operation after placement. Initial cover except in the sumps the latch collection trench of the leak detection secondary latch collection system between the upper and lower liners. The lower geomembrane shall be placed directly on the subbase within the minimum 6 inches thick. Free sharpen the materials. Any of the materials larger than 1/2 of the inch of the saturated hydraulic conductivity less than equal to 1 times 10 to the negative symmetric inches seconds. Synthetic clay liner within a hydrological conductivity no greater than 1 to 10 negative 7 centimeters a second may be used in place with the 6-inch thick subbase layer provided in its place. Unprepared subgrade will not hold and not be damaged with the GCL. The leak detection secondary latch collection system shall have the minimum hydraulic conductivity of 10 centimeters a second. It is designed to limit the maximum hydraulic head of the lower liner with 1 inch. They shall not allow the latch head to exceed the thickness of the drainer layer. The hydraulic conductivity of the leak detection secondary collection system material shall be derived with the transmitted the thickness requirement. Standard geosynthetic component of the HDPGE membranes and LLDPE membranes shall have the factory field seam with the share of the peel of the strength during the testing of the conformance of the seam of the strength specified in the method GM19 PVC geo membrane. PVC geo membranes shall have the factory field seams with a share of the peel of the strength during the testing conformance with the seam of the strength specified in method PGI 1104. For the all geomembrane, the failure should occur with the liner of the material on the outside of the seam area. All field seams must also be visually inspected. Pressure of the vacuum test of the seam, the continuity, using suitable and non-destructive techniques. 3. The 2. The geomembrane shall not be used for the landfill unless otherwise subjected to the continuous spark testing with the manufacturer at the factory. Non-defects that have been found. 3. Geomembranes should be protected with physical damage, placing of the minimum of 24 inches of the protective layer above the upper limit. All materials in direct contact with the liner shall be free of the sharp materials. Any material longer than 1/2 inch of the upper 12 inches of the protective layer shall be composed with the sole tire chip of the 4 square inches smaller than non-protruding with the wires that could pose as a threat to integrity of the liner. The other materials approved with the department which are impermeable or reactive stable within other protection for the liner of the puncture for the first layer of the wall waste placed on the protective layer above the liner and lache collection system shall be in the minimum 4 feet complete with the thickness consistent of selected weight containing low larger rigid objects made with the liner with the lache collection system and materials that could be damaged. The liner should be removed from this layer. The HDP geomembrane shall meet the specification contained in the method of the GRI GM 1311 LLDPE geomembrane shall meet the specification contained with the method GRI GM 17. The PVC geomembrane shall meet the specification contained in the method PGI 1104. Interface shear strength, the actual components for which will be used for the liner system shall be tested as a method of ASTM D5321, hereby adopted and incorporated with the reference equivalence test method to obtain the standard C subsection 62701 21014. Full administration goes, however, when the testing of the GCL as the method of the ACM D6243 are adopted and incorporated with the reference and equivalent test method should be tested and used to obtain the standard see the subsection 62701 21017. The full administration goes, unless it can be justified otherwise, the interface shall be tested in water saturated state. For the purpose of this test, clay is compacted with the test apparatus during the setup, which will have the water content wet optimum shall be considered water saturated. 8. The transmitter of the GeoNet shall be tested with the method of the ASTM D4716, hereby adopted and incorporated with the reference and an equivalent testing method demonstrated with the design test transmitted will be maintained with the design period of the facility. The obtaining of the standard of the C section 62701 210 15 full administration codes. The testing of the GeoNet is liner system that shall be conducted with the using the actual boundary materials intended with the GeoNet maximum design normal load for the landfill as the design load expected with one lift of the waste of the maximum design normal load. Testing should be conducted with the minimum period of 100 hours unless data equivalent to a 100-hour period provided with which one case the test shall be conducted with a minimum period of 1 hour. The case of the disease designed to load for the one lift of waste, the minimum period shall be 1 hour. The GeoNet used in the final cover of only one test should be conducted for the minimum period of 1 hour using expected maximum design normal load for the covering soils and actual boundary materials intended with the GeoNet. 9. The hydraulic conductivity of the GCLs should be tested with the method of the ACM 5887, hereby adopted and incorporated with the reference to ASTM D6766. Hereby adopted and incorporated the reference and equivalent test method to obtain the standard C subsection 62701 210 16 and 62701 210 20. Full administration goes, respectively, first, the GCL testing specimen shall be hydrated with the fluid expected with the cause of the hydration and the field similar fluid with a minimum of 48 hours and sufficient back pressure to achieve the minimum of the B for the coefficient of the 0.9 with the confined effect of the consolidation stress not exceeding 5 pounds per square inch. Then, in the hydraulic conductivity test, the GCL specimen shall be conducted with the using the appropriate permanent fluid at a conductive effect of the consolidation stress not exceeding the 5 pounds per section square inch of the hydraulic conductivity test shall constitute until steady state conditions are reached from the minimum of the 2 pore volumes of the permanent fluid that have been passed through the test. Specimen of the permanent fluid shall be either latchet or from the landfill or other similar landfill. GCL is used in the liner system or water GCL is used for the barrier liner in the final cover. 10. If not submitted as part of the permanent application, the department of the testing requires the subparagraph 3D, 7, and 8, and 9 of the section material used for the liner construction shall be conducted as part of the construction quality assurance activity. The result of these tests shall include the completion of the construction documentation required in subsection S7 for this section. The testing required for the subparagraph 3D, 7, and 8, and 9 of this paragraph single point of the test required either as the part of the permanent application phase of the landfill project prior to liner construction. The purpose of these tests is to confirm that the components selected for the liner construction meet the design criteria for the use in the permanent application. The following specifications shall be provided with the geosynthetic components. Define the qualification for the designer, manufacturer, installer, geosynthetic quality assurance, the consultant with the geosynthetic quality assurance laboratory quality assurance program. Material specifications: geomembranes, geotextiles, geogrids, geocompositable geonets, including general requirements specified the geomembrane properties and labeling. Manufacturing fabrication specification, including geomembrane modification, including raw material and raw quality control, geomembrane fabrication, including requirements the personnel, seaming equipment, and product with the seam, the preparation, whether the condition of the factory seaming overlapping the temporary binding with the trail seam, the non-destructive seam, the continuing testing, the destructive seam, the strength of the testing, including the location, frequency, sampling, procedure, size of the sample testing, at fabrication factor, laboratory testing, the fabricated laboratory testing procedure for the destructive test failure, repairs, geomembrane installation specification, including earthwork and forming the testing, geomembrane placing, which is also address the layout of the drawing, the panel identification, field panel placement, field seaming, the voice shell, address the seam layout, the requirement of the personnel overlapping the temporary bonding with the seam of the preparation, seam of the equipment, the product with weather condition, the seam of the trail seam, the general seam procedures, non-destructive seam, continuity test, destructive testing, and defects repairing, including the identification, evaluation, and repair procedures. Materials in the contact with the geomembrane include the granular materials, the concrete sump, and the appurtenancy line system, the substance, the geotechnical geogrid specification, including handling and placement, conformance testing, seam, the overlapping, the repair of the placement of soil materials, and any overlapping materials. Geonet and the geocomposable specification, including handling and placement, conformance testing, the stacking, the joining, and the preparing and the placement of soil materials, any overlying materials. GACL, the specification, including handling and placement, conformance testing, seams, overlaps, and repairs and placements with the soil materials, any other overlying materials. Standards and soil liner components. Soil components of the liner should be constructed with the greatest extent with the practical lens and cracks and channels and root holes, pipes, and other structural inconsistency that increase the saturated hydraulic conductivity of the soil component. But the design shall illustrate and describe those instances which over excavation of the permeable areas, the backfilling may be necessary to seal the permeable area. The soil component shall be placed in a compacted liner to achieve the design performance. The permeability of the soil of the liner component shall not be increased above the value specified with the component is rolled with the component lache with the solid waste disposal unit compatible with the soil component with the lache shall be demonstrated with the testing the solid soil component with the actual simulated with the lache in accordance with the EPA test method 9100 and equivalent test method. The soil component with the liner may consist of the in-suitable soils and provided with the meet specification for the soil liner testing, and the in-suit soils should be performed in accordance with the site specification, construction quality assurance performance planning in accordance with the subsection 62701-407 and 8. Florida Administration Code. Specification for soil component with the liner shall be provided with approved of the department and shall contain at a minimum allowable range for the particle size distribution, additive limits, and include the Chinkins limits placement, moisture criteria with the dry density criteria, maximum laboratory to determine the saturated hydraulic conductivity uses simulated lache and the saturating testing liquid, minimum thickness of soil liner, lift thickness, surface preparation, scarification of tying lifts together, tying percentage of the clay mineral with the soil component. Soil liner should be placed with using the construction equipment procedure for achieving the required with the saturated hydraulic conductivity. The thickness says a field test section shall have constructed using the proposed construction equipment tested. The documentation desired saturated hydraulic conductivity thickness is achieved with the field to test. The results shall be submitted to the department along with the completion of the construction documentation. Class 3 landfills. A Class 3 landfill should be constructed with the bottom liner consistent with a single 60 mil minimum average thickness of the HDPE geomembrane. In sumps located inside a landfill footprint, the lache collection trenches and the geomembrane shall be placed on the GCL with a hydraulic conductivity less than equal to 110 times 10 to the negative 7 centimeters a second on a compacted clay liner with a minimum of 6 inches with a saturated hydraulic conductivity less than equal to 1 to 10 to the negative 7 to the symmetric centimeter second. Liner shall be placed and prepared and subgraded with the not damage of the geomembrane liner of the GCL with the primary lache collection with the removal system. Drainage liner shall be installed with above the geomembrane liner except for the sump of the lache collection on the trenches. System shall be designed with a limited lache head over the liner during the routine landfill operation. After the placement, initial cover is no greater than 12 inches, and an application may request exemption for the requirements of this paragraph in accordance with the root paragraph rule 62701-342B of the Florida Administration Codes. The lache collection and removal system landfill shall have the lache collection removal system that is designed to construct and maintain and operate with the control of the lache conveying its collection points of the removal of the primary and secondary lache collection and the removal system be constructed of materials that are chemically resistant to the waste of the disposal of the landfill and lache expected to be generated, having the sufficient mechanical components to prevent collapse under the pressure and exerted by the overlying waste and the covered materials of any of the equipment used in the landfill. 4. The granular material in the synthetic geotextile filter overlining surrounding the lashate collection and removal system, the preventing the clogging of the collection system and infiltration of the final particles. And 4. The having the method of testing the pipe of the system are not clogged, the method of cleaning for the pipes in the system, and if they become clogged, if any of the part or of the system cannot be tested for the clogging, the design shall assure that the lashate can be rerouted from the part of the lashate sump in the event of a collapse. The primary lashate collection removal system shall have the granular drain layer above the top of the geomembrane liner at least 12 inches thick, of the hydroconductivity of not less than 1 times 10 to the negative 3 centimeters a second, overlaying the additional 12 inches of the protective material specified in subparagraph 62701-403D3. Fluid administration code, chemically resistant with the waste, the lashate collection system, and incorporative synthetic drainage materials may be used, and it can be demonstrated that they are equivalent to more than effective of the granular design, including the chemical compatibility, flow under load, and protection with the geomembrane liner. The lashate collection removal system shall be designed with the bottom of the slope to achieve the required lashate head over the protected settlement, determine the foundation analysis of the minimum slope of the lashate collection system, and the area to drain with the lateral control collection pipe, the header and pipe. This should be 1% of the after protected settlement. The minimum slopes for the collection pipe of the lashate collection system with the lateral head and pipers shall be 0.3% after the protected settlement, with the minimum slope shall be measured from the peak of the grade with the lowest grade along the design flow path. Slope shall be surveyed after complying with the using of the 50-foot grid in the areas of the drain, lateral collection pipe, the header pipe for the 50-foot intervals where the pipe of the lashate collection system are to be installed. The surveyed slope of them may be demonstrated with the positive drainage shown with the direction of the flow between any of the 2 grids interval points. A scheduled routine maintenance of the lashate collection of the removal system shall be established to ensure operation of the system. The maintenance schedule should be part of the facility operation. Lashate recirculation. Lashate shall be recirculated only in solid waste disposal units with the lashate recirculation system included with the operational plan with which constructed with the operated with the manner consistent with the system. If the lashate recirculated after the closure, the operation plan shall include as part of the approved closure plan. The lashate recirculation shall include estimated impacts on the head of the lashate over the liner substance of the waste and gas production shall meet the following requirements unless otherwise provided approved in the operational plan. Landfills shall be lined and have a lashate collection removal system. Ditches, berms, and other devices shall be installed to control any lashate runoff, initial and immediate covering. Receiving recirculated lashate should be graded with a shred runoff into the lashate collection system to minimize the mixing of lashate runoff of the stormwater, initial and intermediate, with the cover of the permeable to the extent necessary to prevent the perched water conditions and gas buildup. Lashate should not be recirculated during the weather conditions or qualities that may cause the running off of the outside of solid waste disposal units. Surface seeps, the wind blown spray with the exceedance for the limits of the lashate head on the liner of the pounding is prohibited unless it is an integral part of the design plan. C. Landfill gases shall be managed within accordance with the Rule 62701-530 and Fluid Administration Code. Recirculation lasts prohibited at the top of the air with the barrier layer, which is part of the final cover that has been installed with the irrigation of the final vegetative cover may be done with the treated lashate, which meets the water of the quality standard of the receiving the water body in such irrigation that does not contribute to significant lashate generation. Lashate storage tank and lashate surface is impound with the requirements of the subsection applied with the lashate storage tank, lashate surface impoundments construction area. After January 6, 1993, lashate storage tanks in use in January 6, 1993 are not required to retrofit to comply with the subsection unless the leakage, corrosion, or other defects are found. Lashate surface impoundments are in use for January 6, 1993 shall be replaced with the modified to conform with the subsection January 6, 1995. Surface impoundments of the lashate treatment of the storage that are located with the landfills are subject to the following requirements. Surface impoundments must be constructed with the bottom of the liner system and the object of fluctuation with the groundwater so to be adversely impact with the integrity of the liner. The application shall demonstrate that the surface impoundment designed to minimize infiltration of lashate for the environmental so the groundwater, surface water, the quality standards of the criteria are not avoided. The surface impoundment shall be designed within segments so that any within the segment may be taken out of the surface inspection repair with no interpretation of the surface. The impoundment shall have the double liner system with consisting of the upper and lower the 60 mm minimum average thickness of the HEP G membrane leak of the detection collection system between the G membranes. The minimum of the hydraulic conductivity 1 centimeter a second. The lower G membrane should be placed directly to the subbase with the least of the 6 inch thick and has saturated hydraulic conductivity less than or equal to 1 times the 10 to the negative 5th centimeters a second, with a GCL hydraulic conductivity not greater than 1 to 10 to the negative 7th centimeters a second. May be used in place of the 6-inch thick of the sub-base layer, provided the place for the prepared subgrade with it will not meet damage to the GCL. The leak detection collection system shall be checked daily. Design of the upper limit shall be include the calculation to predict the potential leakage for the upper line of the DLA. Checks indicated the upper leaks and is leaking at the rate of the greater than predicted. The design calculation department shall be notified if the leakage rate will result of the flooding of the leakage detection collection system. The impoundment shall be emptied with the liner repaired. 4. To preserve a liner integrity to prevent the uplift of the ballast material such as the round of the gravel sand that will not cause the damage of the geomembrane liner, which shall be placed on the top of the annual liner, which is located below the water. A minimum of 2 feet freeboard with above the depth of which could be occurred with the event of the 25-year, 24-hour storm shall be maintained. Lache surface impoundment. The vectors and off-site odors shall be controlled. Above ground lache storage tanks that are located with the solid waste management facilities are subject to the following requirements. Tanks shall be constructed with the concrete, steel, reinforced polyethylene, fiberglass. Tanks shall be supported on a well-drained, stable foundation. Bottom of the steel tank at the rest on the earthen metal should be cathodic protection with either sacrificial anodes and then impressed with the import current system, which is designed to fabricate and installed in accordance with the engineering plan submitted with the Department. The exterior surface of all steel storage tanks shall be protected with a primary coat, bond coat, and 2 or more final coats of paint. Other surface coating systems designed to prevent the corrosion and deterioration. The interior of all the tanks shall consist of the material must be lined with the material-resistant liner liquid being stored. All the above-ground tanks shall have the secondary containment system, which may consist of the dikes, liners, pads, and ponds, impounds, curbs, ditches, subs, other systems capable of containing the stored lache with the design volume for the secondary containment system shall be with 110% of the volume, either largest tank within the containment system or the total volume of the interconnected tanks, whichever is greater. The secondary containment system shall be constructed with the materials compatible with the liquid storage. The containment system shall be constructed either a minimum 3 or 4 foot 3-foot layer with the compacted soil with the maximum saturated hydraulic conductivity 1 times 10 to the 7th centimeters a second. 1 foot compacted soil with the maximum saturated hydraulic conductivity 1 to the 10 to the negative 8 centimeters a second. With the 2, the protective cover of the concentrating pad with the maintain the integrity of the lifetime of the tank, provided that the tank is made of steel and has corrosion resistant coating. The HDPE geomembrane minimum of their average thickness of 60 mils. The system shall be designed to contain with the remove the storm water for the secondary containment area of the provision shall be included with the removal of the accumulated perception initiated within 24 hours when 10% of the storage capacity is reached, whichever occurs first. The disposal of the stormwater in accordance with the requirements of the subsection 62701-409 Florida Administration Codes. All the above-ground tanks should be equipped with the overfill. The system would include the level and sensor gauge of the higher level alarms, automatic shut-off control of the overfill with the control equipment shall be inspected weekly in the facility operated with the ensure of the good quality, good working order. Exposed exterior with all the above-ground tanks should be inspected weekly with the facility operative adequacy with the catalytic protection, leak or corrosion maintenance deficiency. Interior inspections of the tank shall be performed whenever the tank is drained at the minimum every 3 years, and the inspection reveals the tank of the equipment deficiency, leak, and any other deficiency would cause the release. Result in the failure of the tank of the contained with the lache remedial measures. This should not be taken immediately to eliminate the leak of the correction of the deficiency. Inspection report shall be made available to the department upon the request of the lifetime liquid storage system under lache storage tests and testing. They are located in the solid waste management facilities are subject to the following requirements. Tanks should be constructed with the concrete, fiberglass, reinforced plastic, steel, the cathodic protection with the steel. Steel is clad with the fiberglass. The secondary containment with the continuous leak detection system shall be installed with the form of the double-walled tank design integral structure so that any of the relief in the tank of this is completely contained with the outer shell. Interstitial space shall be monitored at least once per week with the facility operated for the tightness using the pressure monitoring, vacuum monitoring, electronic monitoring. The tank shall be protected with both corrosion primary tank interior with the external surface and for the outer surface. All the resistant coating applied with the primary tank of the interior with the compatible with the stored lache. Cathodic protection systems where installed shall be inspected released weekly by the facility operator. Any deficiency with the cathodic protection system shall be corrected within discovered. All underground tanks shall be equipped with an overfill prevention system, which includes level sensors, gauges, and high-level alarms. Automatic shut-off control. The overflow control equipment shall be inspected weekly, and the facility operated with ensure the good working order. Inspection and leak detection monitoring reports shall be maintained at the facility made available for the department upon the request of lifetime and the liquid storage system liner systems construction quality assurance liner system shall have the construction quality assurance plan to provide the personnel with the adequate information to achieve. Continue in compliance with the liner construction requirements. The plan shall include the preferred of the specification construction method used the established engineering practices to construct liners to provide with quality and control testing procedures. Sample frequency sample testing shall be conducted with the field manual training with the personnel during the construction. After the construction completion, such as personnel will be under the direction of the construction quality assurance professional engineer to ensure liner system will comply with these standards. The construction quality assurance professional engineering of his or design or shall be in design shall be on the site at all times during the construction to monitor the construction activity shall be on the site with the monitoring offloading of the geosynthetics to be used in a linear system. The construction activity shall include the time during the protective layer is installed with the geomembrane to ensure the placement of the technique does not cause damage for the liner system's materials. Liner system shall be installed within accordance with the department approved with the construction quality assurance plan. The plan to comply with the EPA documentation EPA 600R93-182 shall be pre-assumed to compliance with the subsection. The section following the minimum specific elements shall be included within this plan. The responsibility authority of all the organization key personnel involved with the permitting, designing of the construction, provided with the construction quality assurance of the waste disposal facility shall be described in full. Minimum qualification, construction assurance, quality professional engineering supporting personnel shall be in the plan to demonstrate that they possess a training and experience necessary to fulfill their identified responsibility. 3. Procedural tests that will be used in monitoring the installation of the liner system components for this shall be described in detail. The sampling activity, sample size, the sample location, frequency, testing, acceptance, rejection, criteria, plans for implementation, corrective measures that may be necessary shall be described. Reporting requirements and construction quality assurance activities shall be described, including daily summaries, reports, observation data sheets, problem identification, corrective measures, final documentation. All such documentation shall include the final report, which shall be forwarded to the department. Unless otherwise approved with the department at once, of the destructive test samples shall be collected every 500 feet along with the total length of the seams and electrical leak of the location survey. The method, the equivalent non-destructive test method, is used to locate and repair the leak of the installed with the liner system. One of the destructive test samples should be collected every 1,000 feet along with the total length of the seam of the area where there is used, whether this method is used. If an electrical leak with the location survey method or other equivalent method is used to test the geomembrane in the liner system, testing should be conducted after the placement of the soil drainage layer. The geomembrane liner leak location survey shall be performed using the standard industrial methods. Any leak located with the shall be repaired. The tested methods approved by the department. The result of the geomembrane liner leak location survey included the description and location of any leak of the detected with the repairs will conduct with the leaks of the shall documented with the final report, including the completion of the construction documentation required in the subsection. Laboratory experience with the test of geosynthetic and independent of the liner manufacturer installer shall perform the required testing, which may include minimum conformance testing with all the geosynthetic geocomposable testing of the seam shear, peel strength of geomembranes. Professional engineering charge of the construction quality assurance shall provide with a signed and sealed final report record of the drawing of the department stating the liner system has been installed with a substantial conformance with the plans and specification for the liner system. The report and drawing shall be submitted along with the certification of construction completion form 62701-900. 8. Soil liners, construction, and quality assurance. In addition, with the requirements of subsection S7 above, the requirements apply with the construction of the soil components for the liner system. All required testing and analysis shall be performed in accordance with the general accepted engineering procedures of those promulgated with the American Society of Testing Materials (ASTM). Parenthetical references to the ASTM methods are intended as good guidance. Construction quality assurance and quality control plans shall be prepared for each of the soil liner project to outline the project specification construction requirements. The plan shall specify the performance criteria for the soil liner provided with the quality controlling test procedure, minimum sampling and frequency. In addition, with the planning shall define responsibility for the parties that will be involved with the soil liner construction shall present the minimum qualification for each of the party fulfilled with their identified with the responsibility. Field laboratory testing during the liner construction conducted with the qualified soil test laboratory representing the owner. Qualified field technician representing the owner shall provide with a full-time on-site inspection during the liner construction. The field technician shall work under the supervision of the professional engineer with experience with the soil liner construction. Part of the soil liner installation, appropriate borrow source shall be located. Suitable liner construction materials for that source shall be determined in accordance with the following. If the demonstrator of the field experience is available for the least of the 3 of the provider of the successful project of the 5 or more acres, each of the documentation given more borrow source if it can meet the requirements of the project specification for the extent of the laboratory testing of the borrow source will not be required. However, the source of the material shall be geological, similar to the end of the method of excavating. The stockpiling for the material shall be consistent with those used in the prior project. Furthermore, a minimum of 3 representative samples from the appropriate thickness of the institute stratum and from the stockpile of the borrowed material proposed for the liner construction shall be submitted with the independent soil testing laboratory to document through the index testing the proposed material consistent with the material used for the prior successful project. The minimum index testing shall consist of the percent fines, Otterberg limits and moisture content determinations. To have demonstrated with the field experience defined with the above but is not available that cannot be documented with the following requirements shall be met. A field exploration laboratory testing program shall be conducted by an independent soil testing laboratory to document its horizontal vertical extent with the homogeneity of the soil strata proposed for the use of liner material. The sufficient number of the index tests each potential borrow over the stratum shall be performed to quantify the variability of the borrowed materials and to document the proposed material comply with the specification. The minimum of the index test if they shall consist of the percent of the fines at Atterberg limits and moisture content with the determinations. Sufficient laboratory hydraulic conductivity test shall be conducted with a sample to represent with the range and variability of the proposed borrow surface for the ASTM D45084 for each of the sample test specimens shall be prepared tested to cover the range of modeling condition, moisture content, dry density required for the project specification. The hydraulic conductivity test shall be conducted with the triaxial type. If the parameter of the test specimen shall be consulted with under the isotropic condition stress no greater than 10 pounds per square inch of the permitted with the water under the adequate pressure for the achieve the saturation of the test specimen and flow with the outflow through the specimen shall be monitored with the time of the hydraulic conductivity calculated with each of the record flow increment. This shall continue until the steady flow state of flow is achieved. Relatively constant values of hydraulic conductivity are measured in ASTM D45084 of the borrow source will only a considerable super of the hydraulic conductivity of the material conducted with the laboratory test specimen can be shown with the meet and the requirements per project specification at 98% of the confidence level. Part of the full-scale liner installation field test section, the test strip shall be constructed with the site above the prepared subbase. The test strip shall be constructed in accepts and so the measure of hydraulic conductivity of the done distributed sample. The test strip meet the requirement of the project specification 98% confidence level. The test section failed to achieve the desired result. Additional test sections should be constructed in accordance with the following requirements. When the test section shall be the sufficient size such that the full size linear installation procedure can be duplicated within the test section. The test section shall be constructed using the same equipment for spreading, netting, kneading, and compacting. The same construction procedure number that passes moisture addition and homogenization. If needed, they're anticipated with the use during the full-scale liner installation. 3. The minimum linear liner test in section shall be subject to the following field laboratory testing requirements. Minimum of 5 random sample linear construction material delivered to the site during test section installation shall be tested in moisture content ASTM D22 16% fine ASTM D1140 Atberg limits ASTM D4318. At least 5 field densities moisture demonstration shall be performed on each of the lift compacted liner test section. Upon completion of the test section lift of the thickness of the lift, this shall be measured from the minimum of the 5 random location of the check with the thick adequacy. Minimum 5 shall be tubed. The dry cylinder ASTM D2937 of the sample shall be obtained with each of the lift of the test section. For laboratory hydraulic conductivity test, laboratory hydraulic conductivity test shall be conducted with the triaxial type parameters ASTM D5084 with the test specimen should be consolidated under an isotropic consolidation stress no greater than 10 pounds per square inch, permeated with the water under the adequate pack pressure to achieve the saturation of the test specimen. The inflow and outflow from the specimen shall be monitored for the time of the hydraulic conductivity calculated for each of the record flow increment. The test shall continue until a steady state flow is achieved. Relatively constant values of the hydraulic conductivity are measured in ASTM D5084. Full-scale liner installation beginning with only after the completion of the successful liner section of the liner construction quality control testing shall be provided with the document installed with the liner conform with the project specification. The testing frequency control testing is specified below. However, during the construction of the first 5 acres of the liner, these frequencies shall be doubled. The samples should be obtained with the random location selected with the independent soil testing laboratory. If there are indications change of the product of the quality and construction procedures during the linear construction, additional testing shall be performed and determine the compliance. The field testing during the liner and installation of the following field tests shall be performed prior to the laying of the liner material. The liner base, sub-base shall be compacted with a specified density. Density test shall be conducted with a minimum rate of 2 tests per acre. Minimum 2 moisture content field density determination shall be conducted with the per acre per lift of the compacted liner. The degree compaction shall be checked with using the 1-point field proctor test. Other appropriate test procedures, minimum of the floor thickness measurements shall be conducted with the per acre per lift of the compacted liner. 2. Laboratory testing during liner installation of the following laboratories shall be performed. Percent fine with the ACMD 1140 with the linear construction material shall be determined. The minimum frequency with 2 tests per the acre per lift of the installed liner. Ad-Berg limits determination shall be performed. 1 sample per acre per lift of the installed liner. Hydraulic conductivity test shall be tube with the driving cylinder ASCMD 2937. The sample of the compacted liner shall be performed minimum frequency of 1 test per acre per lift. Laboratory hydraulic conductivity test shall be conducted with the triaxial type of the parameters. The ASTMD 5084. Test specimens shall be consolidated under the isotropic conditions. Stress not greater than 10 pounds per square inch, permeated with water under the adequate pack pressure to achieve the saturation of the test specimens. The inflow and outflow with the specimens shall be monitored with the time of the hydraulic conductivity calculated for each of the recorded flow increment. The test shall continue until a steady state of flow is achieved with the relatively constant value of the hydraulic conductivity here measured. F. If the test data, if the liner section does not meet the requirements of the project specification, additional random samples must be tested from the liner section. In such additional testing, demonstrate the thickness and the hydraulic conductivity meet the requirements of the project specification. At 95% of the confidence for the liner section will be considered acceptable. If no liner of the section should be reworked, reconstructed so that it does not meet the requirements of the surface water management system. For above ground disposal, the unit design any feature intended to convey the stormwater to permitted with exemption with the treatment system shall be included in the solid waste construction permit. B. The stormwater or other surface water which comes in contact with the landfill solid waste mixes with lachey shall be considered a lachey and subject to the requirements subsection 62701-500A. The gas control system landfills receive the degradable waste shall be designed and constructed with the gas management system that complies with the requirements of the Rule 62701-530 Florida Administration Codes. R11 landfills and the groundwater landfills constructed so that the bottom of the liner consistently contact with the groundwater is prohibited by this rule. However, an applicant proposing such a design shall include the special design feature to demonstrate the landfill is provided with the equivalent degree of the protection with the environmental as would the similar landfill with the bottom liner is and not in the contact of the groundwater. Such a design is not entitled with the presumption compliance with the performance standards that is set forth in subsection 1 of the section. In addition, any of the final assurance of the responsibility for the closure application shall provide financial assurance in accordance with the Rule 62701-630. Sufficient to ensure long-term maintenance and operational lachey collection system. Rulemaking Authority 403-061, 403-704, Florida State Law 403-0877, 403-702, 403-704, 403-707. Florida State History News, January 6, 1993, amended to January 2, 1994, May 19, 1994, formerly 17-701-400, amended May 27, 2001, January 6, 2010, August 12, 2012, and February 15, 2015. And I'm going to continue reading this in a different video.